With our label in place, let's add another sheet and copy our labels from our previous sheet, and I'm going to use them as my labels for LP problem. Before I start, I'm going to insert a row in between. I'm going to show you in just a minute why. So my first row is the 10 routes that I'm working with in this problem. I'm going to make them bold. The cost is actually my cost per route. Why have I inserted another row here is because here, this is the place where I'm going to place my decision variables. As a decision variable, I want to know that how many units of blood move between cities or while using each route. So I'm interested in knowing the units shipped using each of the routes that is in place. And I don't know this yet, and I want Excel to help me with that. So these are my decision variables. The next thing I'm going to do is I'm going to create my objective function, because once I know how many units of blood are moved using each route, and once I multiply them with the per unit shipment cost for each route, I'm going to get the total cost. So my objective function is going to be the sum product of my decision variables and my cost per route. And I'm going to color it green, and this is going to be a dollar value. Now over here, I need to have information about my cities. So I'm just gonna go back, pick up my cities from previous sheet, paste it right here. I'm just gonna number them because the numbers in label are, my cities are labeled number wise, so these numbers are gonna help me keep track of each route. Now let's start reading each of the route and let's start coding them. Now X14 means this route is originating from Atlanta, which is 1. Its destination is Mobile, which is 4. And let me make it bigger so you can see it. In other words, on this route, there is an outflow from Atlanta and there is an inflow in Mobile. Now in this programming space, we are going to represent an outflow by -1, and I'm going to put it right here, and we are going to represent an inflow by a +1, hence making the sum of each column equal to 0. Because if there is a blood unit that is being shipped from a source to a destination, so it should reach its destination. It can't be just stopped in the middle of the route. And this is our check right here that I've placed, that for each route, the sum of the route should be 0. Through this, we can keep track of, we don't make a mistake while coding this. Now 2 or 5 means there is an outflow from Charleston. There is an inflow in Raleigh. 3-4 means outflow in Louisville, and 4 means an inflow in Mobile. 3-6 means outflow again from Louisville, but inflow in Richmond. And carefully, we're going to just go ahead and keep working our way. The next one here, the -1 +1 flips because there's an outflow from Mobile. It's going to be -1, and their inflow is in Louisville. Then we have an outflow from Raleigh going in all the way into Atlanta. Again, outflow from Raleigh, but this time the inflow is in Charleston. Outflow from Raleigh again, inflow in Louisville. Then we have an outflow from Richmond, inflow in Charleston, and then lastly outflow from Richmond and inflow in Louisville. Let's do our check real quick. And yes, sum of all our columns are equal to 0. That means if we have placed a +1, there is a -1 to balance it out for each route. Let's go ahead and remove it. The next thing we're going to set up are our constraints. The right-hand side of the constraint is representing the demand or the limit for our blood units. So we're gonna label it as limit or demand for our unit. For this, we will be using a formula, and I'm going to write it right here. So our demand is going to be equal to, and let me insert a comment. We are going to calculate our demand by taking the inventory for each city and multiplying it by -1. And here is the reason why we are doing this. If you remember in Atlanta, the demand was represented by a -175. Now the -175 represented that the Atlanta needs 175 units, hence making the demand equal to 175. So on the right hand side, as we are setting limits in terms of demand, so if a city needs units. On the diagram, it was represented by a negative number or a negative inventory, but over here we are going to represent as a positive number or a positive demand. So a negative inventory means there is a positive demand, and if there is a positive inventory, that means that city does not need blood units, so there is a negative demand. We are going to represent this by a positive demand because Atlanta needed 175 units. Charleston did not need any units, it had a surplus of 160, so we are going to represent it by a negative 160, didn't have a demand. Same is the case with Louisville. Then Mobile had a demand for 130 units. Raleigh had a surplus of 125 units. And Richmond had a demand for 70 units. I'm going to go ahead and color code them as red because this is the right hand side of our constraint. Now let's set up our left hand side of the constraint, and it's going to be equal to the sum product of our decision variables, how many units are moved on each route. I'm using the function key F4 to lock them so I can copy this formula in the rest of the cells, and the respective movement from and to each city. Close that, enter. I'm going to copy it right here and color code it. All right, let's test ourselves. If there is a 1 unit moving from Atlanta to Mobile, and I'm going to put 1 here, let's see what happens. So -1 for Atlanta means it's leaving Atlanta, so that means 1 unit of blood is leaving Atlanta, which makes sense, and it's arriving in Mobile, so Mobile is gaining 1 unit right here, represented by 1. If instead of 1, I make it 5. So Atlanta is losing 5 units, represented by -5 in the blue cell, and Mobile is gaining 5 units because those 5 units are arriving in Mobile, so Mobile is gaining 5 units. 5 multiplied by 17 is 85. This way we know that our problem is set up correctly. So let's move on to our next video and set up solver to solve this problem.